7 decades since the Dead Sea Scrolls were discovered, around 80 new fragments of the ancient texts have been revealed to the public.
Portions of the Dead Sea Scrolls are here at DC's Museum of the Bible, removing all obscurity and open for all to see.
For more than 70 years, the world's most famous ancient manuscripts sat inside climate-controlled vaults, photographed, translated, and argued over by generation after generation of scholars. Every conversation about the Dead Sea Scrolls circled the same question. What do these fragments say? Nobody thought to ask a different question until a scientist who had never studied ancient scripture in his life looked at a torn piece of animal skin and wondered something almost embarrassingly simple. What was it made of? That question would eventually blow a 70-year-old theory apart, and it would do it not with new translation or a newly discovered cave, but with a cotton swab, a vial of dust, and a DNA sequencer. This is the story of how genetics rewrote the history of the Bible. The story most people know begins in 1947. In the arid hills west of the Dead Sea, a young Bedouin shepherd was tracking down a goat that had wandered off from his flock. Somewhere along a rocky slope, he spotted an opening in the rock and, almost as a reflex, tossed a stone inside to see if the missing animal might come running out. Instead of a bleeding goat, he heard the unmistakable crack of pottery breaking. Curiosity got the better of him. He climbed into the opening and found tall clay jars lined up in the dark, some still sealed. Inside them were rolled leather scrolls, wrapped in cloth, that had not seen daylight in nearly 2,000 years. He had no idea what he was holding. He simply knew it was old, and that someone, somewhere, would probably pay for it. Over the following decade, archaeologists and Bedouin treasure hunters combed 11 caves near the ruins of a site called Qumran, eventually recovering roughly 25,000 fragments belonging to close to 900 separate documents. Among them were the earliest known copies of biblical books like Genesis, Isaiah, and Psalms, along with texts nobody had ever seen before. Community rule books, hymns, calendars, and vivid apocalyptic visions of a final battle between light and darkness. Carbon dating and paleography place the material anywhere from the 3rd century BCE to just before the Jewish revolt against Rome in 66 CE. It was, without exaggeration, the single greatest manuscript discovery in the history of biblical scholarship, and almost immediately, scholars needed a story to explain it. The explanation that took hold within a few years of the discovery pointed to a Jewish sect called the Essenes. Ancient writers such as Josephus and Pliny the Elder had described a reclusive religious community living in the Judean desert, devoted to ritual purity, strict communal living, and the conviction that the end of the world was near. When archaeologists excavated the ruins at Qumran, sitting just below the caves, they found what looked like a match. Communal dining halls, ritual baths, and a scriptorium where scribes may have copied text by hand. The scrolls themselves seemed to confirm it. Several documents described a tightly organized community governed by its own laws and its own leadership, following a 364-day solar calendar that broke from a lunar calendar used by the priests running the Jerusalem temple. Other texts drip with hostility toward that same temple establishment, describing its priesthood as corrupt and predicting its violent downfall. One particularly striking scroll, known as the War Scroll, described an apocalyptic showdown between the sons of light and the sons of darkness, language that read like the worldview of an isolated, persecuted sect trying to make sense of its own exile. Put it all together, and the conclusion felt obvious. The Essenes lived at Qumran. The Essenes wrote and copied these scrolls. And when the Roman legions crushed the Jewish revolt in 68 CE, the community hid its library in surrounding caves for safekeeping, never to return. This became the standard explanation taught in university courses, printed in museum placards, and repeated in documentary after documentary for the better part of 7 decades. As far as most people were concerned, the case was closed, except it wasn't, not really. Even scholars who accepted the Essene theory kept bumping into details that refused to line up neatly. The scrolls displayed an enormous range of handwriting styles, skill levels, and scribal habits, more than you would expect from a single small, isolated community working in one location. Some pieces of parchment were meticulously prepared, smooth and uniform. Others were rough, uneven, almost amateurish, sitting in the very same storage jars as their more polished neighbors. When radiocarbon testing was finally applied to a batch of fragments in the early 1990s, the dates came back wrong for theory in an important way. Some scrolls appear to be older than the Qumran settlement itself, meaning they must have been written somewhere else and brought to the caves later. Then there was a stranger puzzle that traditional scholarship never fully cracked. If this was really the private library of one disciplined, insular sect, why did it contain multiple, contradictory versions of its own sacred texts? 2 copies of the Book of Jeremiah survive among the scrolls, and they are not simply variant spellings or minor scribal slips. One version is dramatically longer than the other, with whole passages present in one and completely absent from the other, and the chapters arranged in a different order altogether. A handful of scholars floated alternative explanations over the years that Qumran might have been a pottery workshop, a military outpost, or a seasonal estate rather than a monastery, but none of these ideas came with the kind of hard evidence needed to topple a theory that had already been repeated as fact for 2 generations. The tools available to 20th century scholars, handwriting comparison, textual analysis, visual inspection of the parchment, simply were not built to resolve questions like these. That would require a completely different kind of evidence, and it would come from a field nobody expected. In 2012, at a table on the campus of Tel Aviv University, a molecular biologist named Oded Richavi sat down for lunch with a biblical scholar named Noam Mizrahi. Richavi's actual expertise was nowhere near the Dead Sea Scrolls. He studied ancient DNA, the kind of genetic detective work used to trace human migration patterns across tens of thousands of years. But the conversation drifted, as academic lunches often do, toward whatever was frustrating his colleague at the time, and for Mizrahi that meant the maddening puzzle of the scroll fragments. Mizrahi laid out the problem in plain terms. Roughly 25,000 fragments, no page numbers, no way to know for certain which pieces belong to the same original scroll beyond comparing handwriting and guessing at how old and worn the skin appeared to be. It was, he admitted, an inexact science built on educated guesswork, and there was no reliable way to know when that guesswork had gone badly wrong. Richavi listened, and then he asked a question that would eventually upend the field. What are the scrolls actually made of? Parchment, Mizrahi told him. Animal skin. Richavi paused. Parchment as DNA. It sounds almost too simple to be a breakthrough, but nobody in 70 years of scholarship had approached the scrolls that way. Biblical scholars studied ink and letters. Archaeologists studied pottery and ruins. Nobody had thought to treat the material itself, the skin the words were written on, as a source of biological evidence. Richavi realized immediately that the same techniques used to trace ancient human migration could, in theory, be pointed at the animals whose hides had become sacred scripture. Together with Mizrahi and Nina Shore, who oversaw the Dead Sea Scrolls collection at the Israel Antiquities Authority, Richavi assembled a small research team to attempt something nobody had ever tried. There was an immediate and serious problem. The scrolls are irreplaceable and sacred to multiple religious traditions, which meant cutting, drilling, or physically sampling the parchment was completely off the table. Whatever method the team used had to leave the manuscripts untouched. The solution had been sitting in the storage boxes the entire time. Decades of handling, transport, and conservation work had left behind a fine layer of parchment dust settled at the bottom of each container. That dust contained collagen, the structural protein in animal skin, and locked inside the collagen was genetic material that had survived in fragments for 2,000 years. By carefully collecting dust from blank margins and worn edges, places where no ink had ever touched, the team could gather enough material for analysis without laying a single tool on the inked text itself. Turning that dust into usable genetic sequences, though, was brutal, painstaking work. The process of turning raw animal hide into parchment, soaking it, scraping it, stretching it, treating it, damages DNA at a molecular level even before you account for 2,000 years sitting in a desert cave. The iron-based inks used on many scrolls are chemically corrosive to the material around them. And on top of all of that, hundreds of researchers, conservators, and curators had handled these fragments over 7 decades, any one of whom could have left behind modern genetic contamination that would ruin the results. To get around this, the team worked in dedicated ancient DNA laboratories built more like clean rooms than archives. Full protective suits, positive air pressure, ultraviolet sterilization to destroy any stray modern DNA. Before work even began, they developed strict authentication protocols, looking for the specific chemical signatures of molecular decay that only accumulate over centuries, and they ran every sample through multiple independent extractions in separate labs to make sure no single contaminated result could slip through unnoticed. It took years. It required hundreds of samples and no shortage of failed attempts. But eventually, the team assembled reliable genetic sequences from dozens of scroll fragments, and when Reed Chavi sat down to actually read what those sequences were telling him, one result stopped him cold. Most of the fragments came back exactly as expected. Sheepskin, the standard writing material across ancient Judea, taken from an animal perfectly suited to a harsh, arid environment. But a handful of fragments returned something else entirely. Cowhide. On its face, that might sound like a minor footnote. It wasn't. Qumran sits in one of the driest, harshest environments on the planet, right on the edge of the Dead Sea. Sheep and goats can survive there because they are built for scarce water and sparse, scrubby vegetation. Cattle cannot. A single cow needs many gallons of water a day and real pasture to graze on, resources that simply did not exist in the immediate vicinity of the caves. There is no plausible version of a small desert community that was also raising cattle nearby, which meant any scroll written on cowhide could not have been produced at Qumran. It had to have come from somewhere else, somewhere with real rainfall and real grassland, and then been physically carried into the desert afterward. This wasn't a small inconsistency to be explained away with a footnote. It was direct physical proof that at least some of the scrolls originated outside the community. The entire theory was built around. Once the team could reliably extract and compare genetic material, they gained an entirely new ability: identifying whether two separate fragments came from the very same individual animal or from different animals entirely, based on shared genetic markers. For 70 years, matching fragments to one another had relied on visual comparison and informed guesswork. Now, there was something closer to an actual fingerprint. The clearest example involves the book of Jeremiah. Two substantially different versions of the text survive among the scrolls. One closely resembles the standard Hebrew Bible familiar today, longer, with its material arranged in a recognizable order. The other is notably shorter, missing entire sections, with its remaining content organized differently. Before 1947, the oldest Hebrew manuscript available to scholars anywhere in the world dated only to around 1000 CE. So debates about what these divergent versions of Jeremiah actually represented, an early draft, a later revision, a copying error, had never had any physical evidence to settle them one way or another. The genetic testing finally supplied a concrete answer. The shorter version of Jeremiah was written on cowhide. The longer, more familiar version was written on sheepskin. Different animals, almost certainly from different regions entirely. These were not two copies, slowly drifting apart from a shared original. They were two separate textual traditions that had developed independently, in two different communities, likely in two different parts of the ancient world, and both had ended up preserved side by side in the same set of caves. The team found a similar pattern in other texts. A liturgical work called the Songs of the Sabbath Sacrifice, describing angelic worship in a heavenly temple, exists in copies found both at Qumran and at Masada, the mountain fortress where Jewish rebels made their final stand against Rome decades later. Genetic analysis showed that multiple Qumran copies of this text came from entirely different animals, suggesting it had been popular and independently copied in more than one location, rather than being the guarded property of a single closed community. Kinship analysis added yet another layer. By examining specific genetic markers, researchers could sometimes tell when parchments came from closely related animals, siblings or members of the same flock, pointing toward a shared production site and a narrow window of time. And critically, some of these tightly related clusters turned up mixed in among fragments from completely unrelated animals and unrelated flocks. In other words, this wasn't a collection that had grown naturally out of a single scriptorium in one place. It had been assembled over time from multiple points of origin representing multiple communities. If the scrolls really had been the exclusive property of one small, disciplined sect living at Qumran, their sheer diversity makes very little sense. Why would a tightly regulated community preserve competing, contradictory versions of its own scripture rather than settling on one? Why hold on to texts reflecting theological positions the community supposedly rejected, but flip the theory around and the pieces suddenly fit? If these caves function instead as a shared storage site, a collection point where sacred texts too holy to destroy, but no longer usable, were brought from many different communities across the region, then the diversity stops being a problem and becomes the entire point. Jewish law has long forbidden the casual disposal of any document bearing the name of God. Such texts had to be respectfully retired rather than thrown away, often in a dedicated storage space known as a geniza. Geography supports this reading. Jerusalem sits only about 20 kilometers from Qumran, a manageable journey by ancient standards. When Rome besieged and destroyed Jerusalem between 68 and 70 CE, it's entirely plausible that Jewish refugees fleeing the city carried whatever sacred scrolls they could rescue out into the desert, adding them to a collection that other communities may already have been contributing to for generations. Family scrolls, synagogue scrolls, fragments of an entire religious world, gathered together as everything familiar collapsed. Under this interpretation, the caves near Qumran weren't the private archive of one isolated religious order. They were something closer to a communal library belonging to a much wider network of Jewish communities, and the cowhide fragments are physical proof that texts were traveling real distances, carried from wetter, more fertile regions into the heart of the Judean desert. The implications reach well beyond one archaeological puzzle. If there was no single universally accepted version of Jeremiah circulating in this period, only multiple versions, each treated as authoritative by whichever community preserved it, then the same is likely true of Genesis, the Psalms, and other biblical books represented among the scrolls. Canonization. The process of settling on one official version of Scripture was a finished project at this point in history. It was still actively underway, still contested, and the genetic evidence has now demonstrated that fact physically rather than just theoretically. The genetic research, first published in 2020, opened a new chapter in Dead Sea Scrolls scholarship rather than closing one. Before this work, there was no scientific way to confirm whether two fragments belonged to the same original manuscript, whether a text had been produced in one location or several, or whether separate scrolls shared any physical connection beyond a loose similarity in subject matter. Now there is. Researchers are expanding the genetic analysis to a much larger set of fragments, combining it with multispectral imaging capable of revealing writing that has faded past the point of visibility to the naked eye, and building reference databases of ancient animal DNA drawn from across the wider region. The eventual goal is a kind of geographic map precise enough that a single fragment of parchment could reveal, in broad strokes, where in the ancient world the animal behind it once grazed and lived. For 70 years, extraordinary scholars examined these texts using every tool available to them, deciphering difficult ancient scripts letter by letter, reconstructing damaged pages, comparing dialect and theology across thousands of fragments. That work was real, and it was essential. But some questions were simply out of reach using those methods alone. Handwriting comparison is inherently subjective. Visual inspection of parchment can only tell you so much. It took completely different discipline, molecular biology, arriving almost by accident through a casual lunch conversation, to finally answer questions that had sat unanswered for generations. What that evidence ultimately revealed turned out to be far bigger than solving one narrow scholarly dispute. The Dead Sea Scrolls are not the sealed theological archive of one radical sect hiding from Rome in the desert. They are the accumulated, contested, deeply human religious literature of ancient Israel itself, gathered piece by piece from many hands in many communities, carried into the desert by people watching their familiar world come apart around them. A shepherd's stone cracked open a clay jar in 1947 and let that ancient world speak again after 2,000 years of silence. In 2020, a geneticist sequencing dust pulled from the bottom of a storage box finally learned to hear what had been saying all along.